So thank you very much for your introduction. So myself, Raghavendra Ramachandra, I am from Norwegian University of Science and Technology in Norway, and this work is carried out in collaboration with my colleague Hailin. So main idea of this work is to propose a serial network for finger photo verification system, which is more suitable for the smartphone applications. That means that the data what we use to evaluate these finger photo verification systems have been taken from the smartphone capture. So further to analyze the performance of such a network, so we also evaluate some of the not explainably, but kind of interpretable techniques which are widely used in the community. So the outline of my presentation is as follows. So I will provide a very brief introduction on the introduction part, and then we slowly move towards the proposed method, and I will discuss about the proposed network and some of the experimental results and comparison with state of the art and interpretation results will be included in the experimental part. And finally, we draw the conclusion. So as we know that the finger photo biometric systems have been widely deployed, and for instance, like we also have a commercial application from a couple of companies around who can provide as a finger photo based user verification system. So when compared to the touch based sensing, the contactless based finger photo capture has been quite popular because of its scalability and also provides the more information to be captured. So for instance, like in the contact based sensing, so the devices can only capture a small portion of the fingerprint, but however, in the contactless, one can capture not only the fingerprint region in the finger, but also the additional regions in the finger that can also contribute more for the verification information. The further evolution of the smartphone, especially in terms of high-end cameras and high resolution images, and further the user-friendly nature, because the most of this finger photo capture is carried out using the back camera, so that one can hold a camera on one hand, and they can just pose the finger just below the camera to capture the image. So however, the availability of these high-end cameras and high resolution images further allowed the researchers to look for the level 1 and the level 2 features, and now people are trying to explore the level 3 features from the finger photos, which are mainly the sweat pose and those kind of things. So this is the another motivation factor. So why finger photo verification systems are getting more popular nowadays. And another kind of advantage is instead of capturing a one finger, so we can also capture multiple finger all together, so which can also provide a very good verification information and the complementary informations that can be used to verify the given user. So, but however, even though the finger photo verification systems are quite explored, especially in the constrained conditions, when it comes to the unconstrained conditions, especially when we want to capture an image without providing any information to the end user, obviously we face several kind of challenges. The first thing is there may be a smudging noise on the finger, which may be due to the regular use of the fingers, or there may be a poor quality image, especially like because when we use the smartphone cameras, obviously the focus is an issue. So because unless otherwise we click on the focus particularly, so there may be a reason, there may be a chances that the smartphone cameras may be focusing more on the background rather than the foreground. So this is shown in the figure C on the top right corner, so where the focus has been set to the background instead of the foreground. So these things makes the things more complex, and further the usability conditions may also come into picture, because sometimes a user may not aware like how to pose the multiple fingers to the smartphone cameras. So this may also create additional challenge. And more important challenge is the lighting conditions, as shown in the bottom figure. So here we see that like the use of an additional lighting, like in the flash, especially in the room conditions, especially in the dark and especially in the sunlight, can provide a very different information about the same fingerprint. So that means that the lighting plays a very important role in getting the very high quality finger photo images. So when we look into the state-of-the-art finger photo verification system, there exist a wide varieties of the techniques that has been explored more than a decades. So we can see that some of the existing techniques are based on the texture-based approaches, where they use LBP and those texture-based family techniques, where they try to extract the texture information from the fingerprint, and then they try to verify the user. And the second set of the proposed methods are not proposed method, existing methods are based on the minutia-based features. So if we can get a high quality finger photo image, and obviously we can run the existing minutia based extraction techniques and the matching techniques to directly extract the minutia. So however, the quality of the finger photo technique, finger photo imaging can never be compared with the contact based fingerprint images. So that brings additional challenges, but still the researchers are trying to explore the combination of using both the texture and the minutia based techniques, for instance, so that they can plug in the existing cards or the commercial off the shelf of the shelf finger photo verification system, even for the even for the contactless finger photo verification. So in addition to these two techniques, there is also a time frequency based approaches, and there is also the direct evaluation of the cards based techniques. And due to the rapid rise in the CNN based approaches, there is also a deep CNN based features, the way they try to use the pre-trained networks and try to extract the features and perform the user verification. And in some cases, they even try to fine tune the techniques and fine tune the existing pre-trained networks and do the user verification. And the last type of the technique that are popularly used for the finger photo verification is the hybrid. So that means that any of these above mentioned approaches can be combined either at the feature level or at the score level, so that they can further improve the performance. So in this work, we have four different contributions. The first thing is we propose a serial network for the contactless finger photo verification. And of course, we also introduce a new finger photo data set with 196 unique fingers, which are collected from 52 unique data subjects. And this finger photo data set is collected using iPhone 6s back camera, especially with the indoor scenarios. And we collect this data set in two different sessions with a time gap of 7 to 15 days. And of course, we present the extensive experiment by benchmarking the proposed method with six different existing technique, and also we compare our proposed method with cards from Neurotech Verifinger. So finally, we also present four different methods for interpreting our proposed network, which are based on both pixel-based explanation as well as the region-based interpretation. So on the right, this is the block diagram of our proposed approach. So it has four different blocks of convolution layers, and the blocks of residual layers which are connected in the nested form. So our idea here is to use the nested blocks, so that we can address the identity function through the skip connections, and also we can address the vanishing gradients, which are quite normal when we try to train the serial CNN networks. So basically, our proposed method consists of three consecutive layers. For instance, the block 1, block 2, and block 3, or having the layers like convolution, normalization, ReLU, and max pooling. So this combination has been repeated consecutively for the three times, so that we can capture the eye-level features. So these are not essentially the minutia-based features, but these are mainly the texture-based features that we try to extract in the first three blocks. And then after that, when we use these three blocks, in fact, the convolution layer dimension has been gradually decreased by 2. So by doing this decrease, we also notice that we can learn very robust high level features. Especially in the block 4, where we try to bring in the nested resonate blocks. Here we try to use two different kind of blocks. We use both direct connection and also the indirect connections. So idea of the direct connection is we directly plug in from input to output. But however, with the indirect connections, we try to pass the input to convolution and normalization layer before we use the ReLU. By doing these indirect connections, so we can also match the dimension of the input with the output. So in this way, we try to make sure that the information which is processed through the serial network is is less of redundancy, and it is more of complementary information, so that we can do a reliable user verification. So all in all, this network will provide a embedding of the size 1 into 128, and we try to use the cross entropy loss with Adam optimizer. So now with the experimental results, so our database consists of 52 unique data subjects, and we try to take multiple fingers from these user subjects. For some data subjects, we take like 3 fingers. For some of them, we take 4 fingers, depending on their cooperation. So in total, we have like 192 unique fingers. And for all this, we use iPhone 6s back camera with flash on. So these data are collected in the indoor conditions, meaning that the room conditions with windows and those kind of things. And we collect the data set in the two different sessions. So the time gap between these different sessions varies from 7 to 15 days, depending upon the availability of the user. For the each session, we have 200 fingers per finger, which is collected. And the session one, what we collect, we use for the training together with the data augmentation. And for the session two is only used for benchmarking the performance. So here are the quantitative results of the proposed method together with the other existing deep learning based methods for the finger photo verification together with the cards. So we see that here the performance of the proposed method is consistently good when compared to that of the commercial system also. So it is quite interesting to see that like commercial system is having more or less the saturated performance at different match rate, as it is showing the very constant performance across different FMR. So however, the proposed method shows a very improved performance compared to the existing approaches. So further to understand what made the proposed method to give the highest performance. So we try to do the interpretation of our technique on using the four different explainable techniques, which are based on both pixel level as well as the region-based approach. So this is the first result on the interpretability. So the figure A, the top row here corresponds to the enrolled image, and the figure B corresponds to the correctly verified image, and the figure C corresponds to the failure to verified image. So we set the threshold at FAR is equal to 0.1% to perform the verification, and then these results are presented with that particular threshold. As we notice from figure A and B, there is a good correspondence in the deep layer of the grade cam, which shows the similar features has been selected here. But however, for the failure to verify, we see that the way there is a dissimilar features. And similar observation can also be noted with occlusion sensitivity, both at high resolution and the low resolution. And however, even with the gradient attention, so there is also a similarity between the verified and the dissimilarity between the failure to verified cases. But however, with the lime, it is bit difficult to interpret because the results are not very consistent, even though we see that some of the regions in the lime strongly corresponds from figure A to B, but that may not be true with figure B. So because in the figure B also it will show some of the regions are relevant from the figure A. But however, the scores that we got from our proposed method does not correspond to the same thing. And the second part of the interpretability, what we want to try to understand is we try to see like what is the highest score that our system can provide in case of the genuine match case. That means that at very low FAR, like 10 to the power of -4. So what is the score we got? And at 10 to the power of -2, what is the score we got? So that means that when our system performs high verification rate, what regions it is looking into it. And when the system is performing a moderate verification match, that means that at FAR is equal to 10 to the power of -2, what regions the system is looking at. So what is quite interesting to observe here is like when we want to achieve the performance of the proposed method to achieve the high verification match is mainly due to the regions which is surrounding to the core of the finger. So if we design a system, if we design a deep learning system that can force to see around the core region of the finger photo, then obviously the performance of the system, especially in verification, performance of the system will be very good. So this is what we noticed from our proposed method interpretability. So as a conclusion, so we proposed a serial network called Finger-NestNet to perform the finger photo verification. And we benchmarked our proposed method with 6 different state-of-the-art techniques on the newly collected database with 192 unique finger photos. And we also see like what is the reason behind the performance of our proposed method, especially with 4 different interpretation techniques. And the conclusion of our interpretation techniques indicate that the proposed method is performing well because it is mainly looking for the regions which is very close to the core regions where we have a very differentiable information or the very important information that it might be useful for the user verification. So with this I will conclude my talk, and now I am open for any questions.